minus 1.
Right. It's whatever your A and your B are, in this case x and 5, and the middle term tells you whether it's plus or minus squared. Now, that's how, if I just said factor that, then this would be your answer. But because we're also canceling out, you want to go ahead and expand it, x minus 5 times x minus 5. And on the bottom, we have x minus 5. Okay? Because you got 2 of them on top and 1 on the bottom. Okay? So when you cancel out factors of 1, it's 1 on top, 1 on bottom. That leaves behind 1 on top. So what's left on top is x minus 5, and what's left on the bottom is 1. Now, do we need to have the 1 on the bottom? No. Yeah, it's just x minus 5. Now, if the 1 was on top, absolutely we have to keep it, because x minus 10 is not the same thing if you write it on top. Changes the value. Just like 8 and 1 over 8 are not the same thing.
Okay. As long as the 1 is not the bottom.
Yes. If you think of it in terms of numbers, if you had 8 over 1, that's the same thing as 8. But if you had 1 over 8, that is not the same thing as 8. You have to...
On the top one, you wrote the 1 because?
Because everything canceled out, and so I had to put in a 1, and because that 1's on top, you can't just drop it.
So just to, you put the 1 pretty much when they cancel out?
Yes.
And then the first one, you didn't write the 1 because anything, 1 over anything is the equation in the bottom.
Right.
But you didn't have to write that as a fraction. You just could have wrote x minus 10. It would have been the same.
No, it wouldn't. Think of it in terms of numbers. If this were, instead of x minus 10, let's say this was 1 over 8. Okay? Is that the same thing as 8? 1/8? 1/8 is like 1 slice of a pizza, as opposed to 8 whole pizzas. Okay? 1 over 8 is not the same thing as 8. So 1 over x minus 10 is not the same thing as x minus 10. Totally different value. Okay?
What about the...
Now 8 over 1 is the same thing as 8. Sorry?
What about if I flip that sign?
Sorry?
X minus x plus 10.
Uh-huh. Say again, I'm sorry?
What if you
With
flip the
this?
signs?
Oh, if you flip what signs?
You can.
He's saying 10 minus x.
Yeah.
Oh, that wouldn't be the same thing, no.
I mean,
Uh-huh.
minus x plus 10.
Minus x plus 10? You can, but there's no reason to.
But in the
Is that... I'm not sure I understand the question. You mean on this problem right here?
Uh-huh.
And you want to write it as negative x plus 10?
Yeah, because we want to flip that like
To get rid of the 1?
1 in the bottom.
Oh, okay. No, because see, this already canceled out. These are both pluses. You could have rewritten this as x plus 10. But either way, it matches this one, and so that canceled out. But only 2 minuses cancel out. Remember, opposites are both minus. Sames are either both plus or both minus. Opposites are both minus, but they're in the different order. Okay? See, so when they're both plus, the order doesn't matter. They still cancel out to 1. When they're both minuses, as long as they're in the same order, they also cancel out to 1.
they're not in the same order, they will not.
But if it's both minuses, but they're in opposite order, then they cancel out to negative 1. Huh? So both of these pluses canceled out because they're the same. 10 plus x is the same thing as x plus 10. But if they were in opposite order like this, but minuses, then they cancel out but leave a negative sign.
So
Does that answer your question? Okay. And let's see an example. Let's take that further now with this one. So do 20 minus 5x squared over x squared plus x minus 6. So I start factoring. Both the numerator and denominator can be factored in this one. Always ask GCF first. So I had to take out GCF on top. On the bottom, there's no GCF, so I just went ahead and factored A equal 1 trinomial. Do I am all linear yet?
Nope.
Nope. This one, hopefully she can keep going. What do I have? Yeah, perfect squares. Yeah, a difference of perfect squares. No canceling yet. First I have to finish factoring it.
Oh, it would be 4. It would be 2 and then
And 2.
plus.
Right. And yeah, don't make it x plus 2, x minus 2. This is the A and that's the B. No matter how much it bothers your brain to look at it twisted like that, with subtraction you can't just flip the order around. This is 2 plus x, 2 minus x. And yeah, you can change that to x plus 2, but just keep it consistent right now. Okay? So this is a difference of squares. It makes its conjugates, not opposite, conjugates. A plus b, a minus b. This is your a, which is 2. This is your b, which is x. And on the bottom we had x plus 3, x minus 2. Now, do you see anything that is the same or opposites that can cancel out?
Yes. Negative and red.
Right. These are both subtraction, but it's reverse order subtraction. That's what makes it opposites. 2 minus x and x minus 2. So they cancel out, but when you do that, that's only a legal move if you throw a negative out in front.
Oh, really?
Because you are factoring out a negative 1.
Oh, duh.
Okay? They cancel out to negative 1. Now, multiplying anything times negative 1 doesn't change the value. It's also the identity, but it does change the sign. Okay? So if you just cancel out factors of 1, you're good. They're gone. If you cancel out opposites, you're canceling out a factor of negative 1, so you can cancel them out. That's a legal move. Opposites. But you have to flip the sign of your answer. It's like you pulled out a negative 1. Okay, canceled out to negative 1, and you don't have to put it right here in front. You can just put it out front. The effect is it makes the whole thing negative.
Later on in math, later on,
Uh-huh.
would there ever be negative already and we have to flip it?
Absolutely, yeah. Yeah, the whole point is when you cancel out opposites, it flips the sign. So if it was negative to begin with, it would become positive. So we got 5, and 2 plus x, if you want to write that as x plus 2, it's fine. 2 plus x plus 2 means the same thing. You have to leave the parentheses up here because you have an outside factor of 5. And then x plus 3 on the bottom. You can leave the parentheses or drop them on the bottom. Oh, don't forget, that's a negative. Very clear. It's a negative 5 times x plus 2 over x plus 3. Okay. Now, here's a multiplication and a division one, which fortunately isn't any different from what you've just been doing. It just involves a little more factoring. Okay? But the actual factoring and canceling out factors of 1 is the same. Okay? It's just a little more work initially because you have to factor some more stuff. Okay? All right. So let's say you've got negative 24xy squared over x squared minus 49 times another rational expression, 21 minus 3x over 8x squared y squared. Now, I'm going to go through this. I want to make sure and give you this and an example for division too. So the factoring part, I'm going to go through a little quicker. But I'll verbally explain what I'm doing. Okay? But I want to be able to show you the one thing different you have to do with division. When you're multiplying or dividing, so to multiply or divide is the same thing as when you are simplifying. So rational expressions. What you do first is if you are dividing, then you flip the second expression. You take the reciprocal, just like when you're dividing fractions. Dividing fractions just means multiply by the reciprocal. Change division to multiplication and flip the second one. And always flip first, because if you factor first, you often forget to flip. Okay? So if you're dividing, first you change to multiplication and flip your second expression. Then, just as before, you factor all numerators and denominators. Now you're going to have more. You have 2 numerators and 2 denominators now, but you still factor them just as before. And you factor them completely. Start with your GCF and don't finish till you're linear. Okay? And then, same as before, cancel out factors of 1 and negative 1. So no different than what we've been doing before, you just have more factoring to do, but if it's division, you flip the second one before you factor. Now, here, there's no plus or minus here. But this is what I'm going to do. You don't have to do this, but I find it keeps things, instead of having to deal with your quotient rule when things get really messy and your quotient rule and you're using it diagonally, I find it useful to do this. 24 x, y, y. Because x, y squared just means x times y, right? So now you can clearly see one y on top, one y on the bottom. Instead of worrying about your quotient rule where you're like, wait, what's my exponent?
So you can cross up those y's.
Exactly, yes. And on the bottom, I see I've got a difference of squares. And on top, I see I've got a GCF. And on the bottom, there's no plus or minus, but I'll go ahead and expand it out. 8xx, y, y. Because I got x squared, y squared. Then I can more clearly see, cancel out, being fair, one on top, one on bottom. Any questions about the factoring or the expansion?
Oh, okay.
So have you did the reciprocal or not yet?
Oh, there's no, because this was multiplication.
Okay.
So no reciprocal here, only if you're dividing.
Okay.
Yeah. Okay. So if it's multiplying, you just factor completely. But instead of factoring just one numerator and one denominator, you're factoring more numerators, more denominators. Now once you're fully factored, here's how you multiply. Be careful, this is the toughest step. You ready? Boom, you've multiplied.
All the way across?
Yeah, that's it. I mean, it's all multiplication. There's no addition or subtraction. That, you just start canceling. Okay? Don't worry that it's a multiplication problem. It's just still a simplification problem. Now, if this were an addition sign, if this were a plus or a minus, no. Different rules, common denominator. That's next week. But because this is multiplication, boom, you're multiplied. Now you just start canceling. Okay? It's just like it's one rational because it's all multiplication straight across anyway. That's all you were doing anyway. When everything's factored, it's all multiplication. This is all multiplication now, that's all multiplication, so that's multiplication. And so, boom, it's all multiplication. Okay? So it's one big rational expression now. And cancel out anything that matches. For example, the negative 24 and the 8. That you can treat that like a fraction, right? That becomes negative 3 over 1. Okay? 24 over 8 is 3 over 1. Now, can I cancel out these 3's?
Yeah, no.
Why not?
Because they're at the top.
Yeah, they're both on top. Remember, one on top, one on bottom. Those 3's will actually be multiplied, yeah.
Can you cancel out the variables too?
Yes. We've got, how many x's can I cancel out? Yeah, so 1x there and 1x there. You can see by expansion then, that leaves one behind. So I didn't get chaotic with the
So you're
exponents.
going diagonal, right?
Yes.
Okay.
You can go one on top, one on bottom. It doesn't matter if it's diagonal or what.
Okay, so with that 3x, the x minus 7 and x plus 7.
Yeah, and we'll get to that in just 1 second. But we got both y's, right? You're good. Yeah. So 2 y's there, 2 y's there. Yeah. But because I had only 1x here and 2 here, by expanding it, I clearly saw one of each canceled out, but I didn't have to worry about changing my exponents or subtracting my exponents. I just see I've got one left behind. And the 3's don't cancel out. They're on top, and there's no other number to cancel out, and I canceled all the x's and y's I could. So let's look at the binomials. Do you have any matching binomials?
Yes, ma'am. X minus 7.
Yeah. But they're not actually matching. They are opposites. That is a legal move as long as I...
Change your sign to plus.
And it was negative, so now it becomes positive, just like was brought up a second ago.
Okay, so that'll be...
So now let's clean. You might have something else to cancel out. Sometimes when it gets real messy, go ahead and see where you are now, and then check to see. So across the top we have 3 times 3. Everything else canceled out. And across the bottom we've got what's left.
X plus 7.
And it, yeah, we don't have to write the, if there was nothing else we'd write the 1, but there's other stuff, so we don't have to write the 1. Yeah. Times x plus 7.
What did you do? Oh.
Because we still have an x plus 7. Anything that hasn't been canceled out, we just write in a clean order, and we check, okay, yeah, nothing else can cancel out, that's it.
But if I did it the opposite
And it
way-
became positive because of my canceling opposites. Sorry?
Oh, never mind, because I couldn't, that was stupid. Because I put parentheses x plus 7,
Uh-huh.
and I plus 1, but you can't, you have to keep it in order.
You see why? Okay. All right. So right at the end here, I don't want to rush too much. I'm going to do the factoring pretty quickly and point out a couple of things, but just so you have one last example for division, then when I turn it over to you for homework, it's all about working out all that factoring stuff. but the process is all the same. And your goal and homework is to stay as clean and organized as you can, and as fluent with your factoring skills, so you keep everything clean and organized and non-chaotic, and you just follow these same steps. This is all multiplication and division. In this case, this is a division problem. Now, if I start factoring before I deal with that, I might forget to flip. So flip first, then factor. So I just rewrite the entire problem. It becomes times the reciprocal. Just like when we're multiplying regular fractions. Dividing regular fractions means multiply by the reciprocal. So that's what I'm doing here. I write the reciprocal, so I change it to multiplication and the reciprocal.
All the way through.
The first one doesn't change, because this is just like when you divide fractions. If I had 3/5 times 1/2, well, I just multiply straight across, right? That equals 3/10. But if I have, like, say, 3/7 divided by, say, 2/3, well, that means 3/7 times 3/2. Right. So dividing just means multiply by the reciprocal. Now I multiply straight across and I get 9/14. And that's all you're doing here. You're just doing it with big, uglier, messier fractions, but it's the same idea. So you have to division, change it to multiply the reciprocal. Now start factoring. Okay. Now my eye really wants to see x squared minus 4 as conjugates there. Is it? No. It's a GCF. I pull out that x, I'm left with x minus 4. Oh! Careful, careful, careful. GCF first, and what your eye wants to believe is a difference of squares turns out to not be. Because I pull out a GCF of x and it leaves behind an x minus 4. Okay, so that's done. It was quadratic, so I got my two factors. Here, now this is my difference of perfect cubes, so I'm going to use my SMS, so it makes it simple. Go off on the side and do that. What that gives me is a binomial of x minus 4 and then a trinomial of x squared plus 4x plus 16. Okay? And if you go off and do your SMS, so it makes it simple, you'll get your binomial times your trinomial. So you recognize, oh, difference of cubes, I'm going to get a binomial times a trinomial. Take care of that. Okay? Times, okay, this is a trinomial. Oh, I got a GCF first, so otherwise I'm not going to worry about it. So 2 times, I can factor out a 2, leaving behind x squared plus 4x plus 16. And 2x is just 2x. Okay? So, flipped and then factored. And factored by whatever methods, GCF, difference of squares, sum or difference of cubes, trinomials where a equals 1 or a doesn't equal 1, 4-term grouping, all of your skills will come into play. You've got to see, what do I have and how do I know I'm done? Now, am I done yet?
No.
Because these aren't linear, right? Now, here's the thing though, when you factor a difference of sum of cubes, the trinomial you get is generally prime. Okay, that'll be it. That's done. You can't factor this trinomial anymore. If you went from a difference or sum of cubes, then the trinomial in your factorization will be prime. So if you're done, you're done. But what do you notice? Yeah, even if it's not linear yet, if it matches something else, it's a factor of 1. So this is also, when you pulled out that GCF here, you're left with a trinomial, and you might think, oh, I need to try and factor it. But if you try and factor it, you'll find it's prime. Okay? No harm if you try, but hopefully you'll notice, oh, I should have noticed that because I know this one's prime, and if it already matches, I know I don't have to keep going. I can just go ahead and cancel it out. Yeah. You couldn't factor it anyway, but regardless, as soon as it matches, it can go.
Okay, gotcha.
Oh.
What about the x minus 4?
The x minus 4, absolutely. There's another factor of 1. And what about this?
Yeah,
Yeah.
Oh, yeah.
And if you're like, oh, I'm a little messy, let me just clean it up first and then reevaluate it. Well, across the top, I've got an x and a 2 left, right? And on the bottom, I have a 2x. Yeah. I'm not done yet. What does it equal? 1. All of that. Down to 1. That's the grand finale where everybody gets a little mad at me. Like, all that work for 1? I used to have a student who was so mad at me anytime the answer was 0. And I'm like, 0 is an awesome number. It's like, all that work for 0? No, she got really mad. that she hated when the answer was 1 or 0. I think it's beautiful, though, right? It's so clean. So that's what you're going to see on this first homework. The first half is about understanding functions, evaluating functions, finding the restrictions and domains. And the second half is about simplifying. Simplifying, multiplying, and dividing, which is all about factor completely and find your factors of 1 or your factors of -1 and cancel out. All right, and I will be down in the lab in 10 minutes.